Hello everyone, and welcome to this live webinar. Today, you will learn more on emergency stop switches. The question is, would you trust your e-stop with your life? In other words, would you put your life in the hands of your e-stop? You can post your questions on the chat or even by email at vivien.rino@apem.fr for those who have no Google account. We will answer your questions during the last part of the webinar. E-stop switches are critical components for the worker safety and is the last possible measure to avoid accidents. So we are clearly talking about a critical and serious topic that can be a matter of life and death. Today's webinar is about the emergency stop switches. We will start with the standards. Many international standards have been written to ensure emergency stop switches meet both functional and structural requirements. These are the basic things you get when you buy an emergency stop switch today. Upon performing an FMEA, failure mode effects analysis, on emergency stop switches compliant with international standards, we have found that conventional emergency stop switches do not stop machine operation in some foreseeable situations. I call it foreseeable failures or misuse. We will list them. And in the final part, we'll see how to overcome these failures. If you have any questions or comments, I'll be very glad to cover them after this presentation. You can post your questions in the chat. Please note that you'll need a Google account to proceed. If you have no Google account, just send me your questions at vivien.rino@apem.fr. You can see my email address here. This session is recorded. We will share the link by email after this webinar. At the end of the webinar, we will also share this presentation. Let me introduce myself first. My name is Vivien Rino, and I am a member of the IDEC experts dedicated to the IDEC switch range. I have a master's degree in electronics and mechanics engineering. I have worked during 8 years as a product manager, developing and promoting accessories in the electrical distribution network and served all the major utilities around the world. Then I've joined APEM to promote IDEC switches early 2018. I am still very involved with the customers to advise the right solutions for their applications. I am working for APEM, which is part of IDEC. We have developed solutions for our customers since 70 years. Today, IDEC and APEM represent 23 factories, 3,900 employees, and more than 100,000 references. APEM oversees the promotion of IDEC products in Europe with dedicated support teams and stock. IDEC is renowned for its best-in-class products in the industrialization automation and is part of the International Standardization Committee. IDEC ranges include all the products you need for the safety, industrial switches, automation of course, sensing, and industrial relays and components. So let's come back to our topic now about the reliability of the e-stops and start by the basic and mandatory features of the e-stop switch. If I ask you again the question I asked at the very beginning, would you trust your e-stop with your life? It would be a clear no for this one. No need to vote. This is obviously a joke, where at least it cut the power, but not sure what would happen next. Of course, this e-stop, if I can call it an e-stop, does not follow the basic principle as given in the standards. An emergency stop function is framed by international standards, starting by the ISO 13850, which, by the way, has been recently updated in 2015. We did a white paper presenting all the major updates. This standard describes the e-stop function. It includes the input, logic, and output that operates the emergency stops. Even if it deals with the e-stop function, it gives crucial restrictions on the e-stop switch, like the safety lock mechanism, the color code, and so on. According to this standard, the machine designer must ensure the function is at least rated performance level C, as per the ISO 13849-1. As part of the function, the B10D of the e-stop device is needed to make the calculation of the performance level. The B10D is the number of cycles where 10% of the component fails to danger. For IDEC e-stops, it is usually 100,000 cycles. The e-stop device itself is covered by the IEC 60947-5 Part 1 and 5. It covers all the basic and mandatory features your e-stop switch must have. Direct opening action contacts, shown by this logo, safety lock mechanism, panel mounting structure so the e-stop switch cannot be removed from the front of the panel, reset method, etc. So we are pretty well covered. The e-stop is designed as a secondary safety measure, preventing the machine from injuring the user in the event that the primary safety was not sufficient or when all the other safety measures failed. That's why an e-stop failure is likely to lead to a disastrous situation. In a perfect world, we would never need to use the e-stop. Even if the European Machine Directive is now about 15 years old and the safety devices are improving, there are still too many people dying in the factories. More than 5,000 in the US, 3,300 in Europe, which is in total the equivalent of 47 full A320 crashing every year. So it clearly means that the unforeseen situations are still happening. For an operator faced with an emergency situation, using emergency stop switches is the last possible measure to avoid accidents. So we need reliable e-stops. As a conclusion, the e-stop standard is very useful to ensure how the e-stop behaves in a standard manner. Emergency stop switches, which are compliant with standards, are, when properly installed and operated, generally free from problems. But as I have explained, the e-stop is here especially for unforeseen failures, and if all the other safety devices failed. It is difficult to standardize a device that must work in non-standard cases, and it is your responsibility to adapt the e-stop to your machine and the situation. The e-stop is designed as a secondary safety measure, preventing the machine from injuring the user if the primary safety was not sufficient or when all the other safety measures failed. That's why an e-stop failure is likely to lead to a disastrous situation. E-stop switches are a bit like your circuit breaker at home. It is a device that we hope we will never need and we never use it, but if we need it, it must work. Now that we understand the standard frame, we have to pay attention to the fact that humans will make mistakes and that emergency stop switches may be hit with excessive force or may be installed improperly. Let's see the foreseeable failures that could happen in the e-stop device lifetime. Even if an e-stop sticks to the latest standard, it does not cover the failures which would somewhat be foreseeable, especially during the installation process and then during the operating process. Let's review these failure modes. The very first one is linked to a bad location. The e-stop works, but it's just not placed at the correct place. In this picture, it is obvious, but it may not be that easy to find the correct location. Another issue can be linked to partial stops, so you do not know which e-stop would stop the part of the machine or the entire machine. So the second case, and probably the worst case, is linked to the product installation on the panel. The product is correctly wired and the machine will run because of the normally closed contacts, but the contact block is not safely fixed on the actuator, and as soon as the button is actuated, the contact block will fall and the machine will keep running. This failure mode can happen when the space below in the panel is limited and the technicians did not insert the contact block or forgot to turn the safety lever. It is one of the worst cases because it cannot be seen from the outside. Let's consider a regular e-stop. When the light is on, the machine is running, and we have a potentially hazardous situation. When the light is off, the machine stops. Once our installation is secured, what could go wrong? During the operation process, the common failure mode is caused by impacts and shocks. As you can see, the e-stop is damaged, but the machine keeps working. E-stop switches must satisfy the requirements of the IEC 60947-5-5 Part 773, which is the impact test for button type actuators. The emergency stop switches are, as the name suggests, likely to be used in highly tense situations. In such situations, some people tend to tense up. Some other might mistakenly drop the device. Moreover, the e-stop buttons must be highly visible and accessible according to the standards. Therefore, the impacts and shocks on the device are likely to hit the e-stop switch and break it. That will cause possible danger to the operators since this machine can no longer be stopped. This failure mode can happen especially on portative devices like on AGV. It could also happen on embedded e-stop like forklifts if something heavy is falling on the e-stop mushroom. Sometimes the product is hit intentionally with a hammer or something else depending on the action the worker was doing when the hazard happened. To summarize, here are the main foreseeable issues that can happen on an e-stop device during its lifetime. During the installation process first, the product may not be located at the right place or not correctly mounted. During the operating process, the e-stop may bear intolerable impacts and shocks. Now, how can we overcome these common failures? Let's start with the bad location. In this case, the risk assessment performed for a machine should determine the best locations for e-stops. It should be next to the working areas, at gates, inside and outside the fence. The risk assessment should be performed according to the ISO 12100. The ISO 13850 gives you some pieces of advice where the e-stop should be located on a production line. You can refer to our white paper on the new update of the ISO 13850. Please note that IDEC has a dedicated team of safety specialists who can assist you in this process. Last but not least, you may have a dedicated standard for your machine. Now let's see what we can do to avoid and detect the bad mounting. The first option available on the market is the self-monitored contact block. It is a contact block that detects the presence of the operator. There are two contacts in series. The usual normally closed contacts stops the machine when the e-stop is pressed, and a normally open contact that operates with the presence of the operator. If the e-stop is correctly mounted, the machine is running. If the button is pressed, the first contact, normally closed contact, opens and stops the machine. If the operator is removed or if the contact block has not been properly attached, the second contact, the normally open contact, will open and keep the machine on a safe state. The other solution is IDEC original safe brake action. The spring is mounted the other way round compared to the regular e-stop. When properly installed and not actuated, the spring is compressed and the machine is running. If the button is pressed, the spring is released and opens the contact, stopping the machine in a safe state. When removing the contact block, the actuator releases the spring, and even if the contacts are welded, the normally closed contacts turns off without failure, stopping the machine operation thanks to the direct opening action. I'm back with our basic installation. Again, once the light is on, the machine works, meaning that hazardous situations can occur. When the light is off, the machine is off as well. As you can see, each time the contact block is not attached to the mushroom, the machine is held in a safe mode. As a conclusion, mistakes can be avoided during the installation process by making a risk assessment and ensure that the e-stop is always at the relevant locations. It is mandatory to add the CE marking and must be done in accordance with the European Machinery Directive or the ISO 12100. The bad mounting can be addressed by training the technicians, but it will not remove the human aspect. The best solution in that case is to either use the IDEC original safe brake action or the self-monitored contact blocks. Now that our e-stop switch is correctly installed and secured, how can we deal with the operating process issues? The very first solution is always to do a visual inspection of the machine before starting it. It is highly recommended anyway. The second option is to add a guard. It is now tolerated in the 2015 version of the ISO 13850. IDEC has a full range of switch guards with different shapes and sizes. The third option is to use a metallic product that would withstand higher impacts. The last solution is the IDEC original safe brake action. The spring is mounted the other way around in the contact side, but also in the mushroom. So as soon as something is broken in the contact side or on the actuator side, the spring is released and will stop the machine in a safe mode. Therefore, we call it safe brake because it will always brake or fail in a safe mode. Hey, it's me again. Happy to be your Guinean pig again. This section shows two e-stops. One without the safe brake action is broken and the machine still runs. In that case, the e-stop is broken and can no longer stop the machine. The other one has IDEC original safe brake action, which stops the machine in a safe mode. As you can see, the contact block is still connected, but the light, so the machine, is off. During the operating process, it is highly recommended to perform a visual inspection before starting a machine. It is free and easy, but very randomly and rarely done. It will also depend on the ability of the worker to identify the defect. The guards are now tolerated, but not encouraged, as it reduces the accessibility of the e-stop. Then a metal e-stop could be used to replace plastic ones. It gives a comforting feeling for the designer because metal often means rugged. The issue is that it is very difficult to foresee the exact maximum impact or energy a button should withstand. I know it is very difficult to rate an impact and give the corresponding IK level. Also, fully metallic products are scarce. Very often it's a mix of plastic and metal and expensive. Also, metal does not mean that it is not affected by the impacts. If the metal parts does not break like plastic, the impact might distort the metal parts and the e-stop may not work anymore. And it will hardly be detectable during a visual inspection. The solution to prevent all kinds of failures is the IDEC original safe brake action. Unlike the self-monitored contact blocks, it will always break or fail in a safe mode, or if it is wrongly mounted. The self-monitored contact block will not stop and protect the worker in case the mushroom is broken, relying on the ability of the worker to detect this failure mode himself. The e-stop with the IDEC original safe brake action is the most reliable. If I answer the very first question, would you trust your e-stop with your life and the ones of your workers? With the IDEC safe brake action, it's a clear yes. Thank you very much for watching us. We hope you enjoyed this webinar on watching me breaking some e-stops. As a thank you for turning up, and before I answer your questions, you'll get an email to download this presentation, discover our product range in the brochure, have a meeting with one of our safety specialists, and get a free sample. For this last point, I will of course need your postal address to send it to you. Please just send me a request at vivien.rino@apem.fr. We have several products cut out, so let me know which product you are interested in.